Right class, now we are going to chapter 2, which is vector. Okay, what is vector? Vector is a quantity that has both magnitude and direction. So vector, it has both magnitude and direction. Okay, let's say this is vector O to P. Okay, so this is magnitude. What is magnitude? Magnitude, that means length dia. Okay, length dia. And then direction from O to P. So this is direction dia. Direction dia from O to P. Okay, this is vector. What is scalar? Scalar is a quantity that has magnitude only. Okay, scalar, it has magnitude only. Okay, for example, for scalar, distance, length, speed, time. So that is scalar. Alright, so from for vector O to P, okay, from the tail of the arrow, okay, from the tail of the arrow, we known as origin, okay, or initial point. Okay, for point P, it is a terminal point. Okay, vector OP, okay, vector OP is equal of vector A. Okay, it is known as vector A also. Where is the vector A? Dekat sini, let's say. Okay, you can call vector OP or vector A. Okay, we use a small letter for vector A. Alright, it is the same vector. Okay, so for vector, I want to explain about the definition of vector. Okay, boleh nampak lah. Alright. First one, the two vectors are equal. That means, let's say this is a vector A. We have vector A and we have vector B. So, the two vectors are equal. That means we have the same direction and same length. Alright. Same direction and same length. That means vector A is equal vector B. They are parallel. Alright. For number 2, vector has opposite direction. Let's say we have a vector A and we have another one for vector A, but different direction, opposite direction. That means different direction. So when it's different direction, it is denoted as negative vector A. Okay, number 3, sum of vectors. Sum of vectors, that means, let's say this is vector A and vector B. Okay, sum of vectors, that means we can add these two vectors, vector A and vector B, by joining them to make a vector C. To make a vector C. Therefore, vector C is equal vector A plus vector B. Nampak dah? Alright, sum of vectors. Okay, by joining these two vectors, vectors A and vector B, to make a vector C. So, vector C is equal vector A plus vector B. Alright, and then number 4, difference of vector. Difference, okay, tadi sum of vectors, that means by adding. Okay, difference of vector, that means subtraction. Okay, let's say we have a vector here, vector A and vector B. Okay, and then we have another one for vector B, but different direction. When it's different direction, that means negative vector B. Okay, so we can add these two vectors, okay, vector A and vector negative vector B, add these two vectors, joining them to make a vector C here. So that means vector C is equal vector A plus negative vector B. Therefore, positive, negative, it should be negative. So therefore, vector C is equal vector A minus vector B. Alright, it's the difference of vector. Number 5, product of vector. Product of vector, it means we have to multiply by scalar. Okay, multiply by scalar. What is scalar? Okay, let's say this is vector A. And we have another one for vector A, but half of vector A. Okay, so half 1/2 it is denoted as scalar. 1/2 ni adalah skala dia ataupun length dia. Okay, dia punya kepanjangan dia for vector A. Okay. And what about we have another vector A but twice. Okay, we have another vector A but twice. 2 kali vector A. 2A. Okay. But different direction. Sorry. Nampak tak? Okay, but different direction. We have pada asalnya vector A. And then we have twice of vector A, 2A, but different direction. When it's different direction, we have to put negative. So, -2 is a scalar. Okay, product of vector ni, that means we have to multiply by scalar. So, -2 ni is a scalar of vector A. 1/2 is a scalar of vector A. Okay, multiply it. Alright, so this is product vector. Okay, so for vector we have coordinates. Okay, vector we have coordinates, whether it is in 2 dimension or 3 dimension. Okay, for 2 dimension that means x, y. Okay, boleh nampak dah. And another one 3 dimension. 3 dimension that means we have x, y, and z. Okay, for 2 dimension, okay, let's say saya lukiskan graf dia for x axis and y axis. Okay, let's say we have a vector OP. So we know that from point O ni, it is from origin. So the coordinates for O is 0, 0. And coordinates for P, let's say I put 2, 3. Okay, and we have a vector OP. Okay, this is 2 dimension. Okay, how about 3 dimension? Okay, for 3 dimension, that means we have x axis, y axis, and z axis. Okay, so let's say we have a vector here, O, P, vector O to P. Okay, so macam mana nak lukis for 3 dimension? This is y. Okay, for 3 dimension, dia punya vector OP dia, it will be like this. This is 3 dimension for vector OP. Okay, and then let's say this is dia punya point x, y, z. Okay, so in 3 dimension, we have to know the position vector of point P. We have to know the position vector of point P for value x, y, and z. Okay, we see that for value of x, okay, we want to know the position for x. Okay, we know that for x, it is parallel to x-axis kat sini. So the position for x-axis, it is denoted as I. For value y, okay, value y, it is parallel to the y-axis. Okay, y-axis kat sini. So position for y-axis, it is denoted as J. And last one, for value z, okay, it is parallel to the x-axis. Z-axis. z-axis dekat sini. Okay, so the position vector for z-axis, it is denoted as k. Okay, ijk ni apa? Ijk ni adalah position vector for x, y and z. Okay, position vector. So, position vector, kalau tengok pada notes tu, 2.5, page 22. Okay, page 22 tu. Okay, position. Dia punya position vector dia. Position vector, it is denoted as vector r. Okay, and it can be written as xi plus yj plus zk. Okay, yang atas ni kena tulis jangan hilangkan yang atas ni. Alright, yang ini menunjukkan dia punya position vector for x, I ni, and then j is a position vector for y, k is a position vector for z. So let's say we have a point P here. We have a point P, let's say I put 2, 3, 4. Point P for x, y and z. So the position vector for point P, okay, the position vector for point P, vector r, or kalau awak tak nak letkan sebagai vector r, if you want to let as vector OP here, also can. Okay, vector r is equal vector OP. Kalau awak tak nak let vector r, you can also let as vector OP. So it is equal for x is 2. Okay, boleh nampak For x is 2i plus 3j plus 4k. So this is a position vector for vector OP. Okay, 2i plus 3j plus 4k. Alright, boleh faham dah? This is explanation for vector. Okay, position vector dia. Okay.